So an example of like this is that, for instance, 1, 2, 3, where this is B, and this thing A is -1, so basically it's not possible. So let's see why. So here in B naught is A naught and A1. So remember, so B naught is 1, so it's 0, 1. So in order for this to be true, A naught and A1 must. So A1 obviously, sum 1, you need A0 and A1 to both have these. It doesn't really matter what's in between. It doesn't matter what A naught is really, but let's just make A naught 1. Let's make A1 whatever it is, right? It doesn't really matter. So now B naught, B1 I mean, sorry, B1 is A1 and A2. And B1 is, I believe, 2. So A1 has to be bitwise AND of A0 and A2, and also have to accept A2 as well. So just going to give you an example, A1 and A2. So the end result has to be 1 and 0. So basically this has to be false. We know that A1 is 0 and 1 for some value and other values. So A2 here, it has to be false. So it must be a 0 here. Yeah, and here also it has to be true as well. So this must be a 0 as well. So A2 has to be 0 for this to be true. And now, last but not least, B2 is 3. 3 is just 1 and 1. And because A2 is, so A2 and A3 has to be 1 and 1. So we know that A2 and A2, so I guess A3 can be 0 and 0. So this is, I guess, true? Which I'm confused, so why is it saying it's not true? So what's happening is that basically so 1 1 0 0. Let's try it. So B naught is 0 1 0 1, which is 0 1, which is just 1. B naught 1 is basically 0 1 and 0 1. So this is 0, which is 2. B3 is 0 0 and then 0 0, right? It's 0 0. So this is 1 1 3. This should be true. Okay, so why is it showing it's not?
Le soleil,
Hmm.
le soleil, 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 soleil,
Interesting problem. Yeah, I'm just at a loss of how to solve this problem. next one is 7 and 5, I believe. So 7 is number 1. 5 is 1, 2. This is 1, 0, 1. This is 5. This is 0. Next one is 5 and 6, which is, I believe, 1, 0, 1. 1, 0. This is 1, 0. This is, I believe, 4. No, last but not least, 6 and 3. This is 1, 1, 0. 1, 0, 0. I believe, no, no, no. There should be 1 here. This is 0, 1, 0. This is 3. So, wait, sorry, this is 2. Sorry to change. I was basically just testing. That's testing the fourth case. Either way, so what I'm kind of seeing with this problem is that the problem seems to be for, let's say, A1, it has to basically be A0 and A1 and A1 and A2. Wait, I think I'm writing wrong. So remember that B not is A0, 1, 2. So you can kind of put, well, I guess solving for A1 is just, how do you even solve for this? Cause what would you say? What would you say? A not is simply just. It's hard to kind of determine a solution from this, because the equation itself is. Because B not, we know B not, we know B1, we know B2. What is A not in sense?
What are you doing? I'm just looking at the world.
Yeah, I don't have any type of clue as to how to solve this. Yeah, it's just like, I guess the problem right now is understanding how to, I guess, this team is run. I would just assume it's just, because, like, let's put it this way. We know that 7, not 3 is 3, correct? But, you know, so let's say I want to solve for, let's just give it, this is obviously A1 and A not, and this is B not. And we know that, what is it, sorry, 5 and 7 is 5. A1, A2, B1. So, again, let's just say I hypothetically assume you don't know these values, correct? You don't know these values here. How would you solve for them? That's kind of where I'm at right now. So what the direction I'm trying to see is, one, we notice that the value A naught and A2 seems to be. Well, that's not necessarily gonna be true, but fudge, bro. It's kind of a hard problem. It's easy but at the same time hard. It's weird. I guess that's a good question. How do you even solve these big massive equations? Oh, I see. So essentially, it's kind of like this. So, like, let's just hypothetically say there's 5 and 4, right? Which is B1 and B2. And this is 1, 0, 1, and this is 1. I believe this is what again? Sorry. Yeah, 1, 1, 0. So in order for this to be true, we need 1. So this is 1 here. Doesn't matter. 1 here and 1 here. So the answer here is 7. we already kind of solved x in a sense. X is 7 because in this equation we get 3 is 0, 1, 1, 5 is 1, 1 to 1, 0, 1. Essentially anywhere there's a 1 is a 1. Yeah, so it's basically just an OR of and that's kind of where I was kind of seeing, right? Where let's just make A naught equal to B naught, right? And then B, so sorry, A1 is simply just let's just say B naught or B1, and A2 is B. But then what is A3 in a sense? Well, because there's no so A2 in a sense would be B, what is it? Sorry, B1 and or B2. A3 is simply just B, I believe 3. Okay, there's no 3 anymore. But just to give it a test. So A naught and A naught is just to kind of A naught is 3. A1 is 3, 4, 5, which is 7. A2 is 5, 4, 4, which is 7. And this is not true. I'm going back to square one. To square one, where we said that x is not 3, x 5 is 5. We want this type of equation where, in this sense, x is a1 or ai, if you will. We have to look at the equation itself. We're looking at the equation itself. So remember that a naught and a1 is b naught. We know what b naught is, but we don't know. And I guess we do know what a naught is because it's just. Let's assume that it's b. So we're kind of solving for a1 in a sense, right? But the thing is, we don't know. It's here a1 and a2. So, should I drop this? Should I drop it? I kind of already solved this. So that, I guess the idea should be dropped because I can't really find a solution. So I'm just gonna look at the tutorial and see how we solve this.
On to the second problem. It says you are given an array B of n minus 1 integer. An array A of n integer is called good if Bi is equal to Ai and Ai plus 1, where and denotes bitwise AND operation. Construct a good array or report no such good array exists. Like here, like you can also find bitwise AND definition here. Like the crux of this problem was, let's first forget the first and last element. Let's pick any element Ai where 1 is greater than I and I is less than n. Then this is part of two ends. Like we know that Bi is equal to Ai and Ai plus 1, and Bi minus 1 is equal to Ai minus 1 and Ai.
Mm-hmm.
What does this statement means? Let's say fifth bit is on in Bi. And because it's an AND operation, if fifth bit is on in Bi, it means fifth bit is 1 in Ai and fifth bit is 1 in Ai plus 1.
Not necessarily. Wait, oh shit, is that true? Oh yes, it is. Yeah. Because I think that if it's 0 and 0, it could also be no, but that's
And so on. And so what you see is like if you look at all the bits which are on in, and similarly all the bits which are 1 in Bi minus 1 or Bi should be 1 in Ai. Any questions for the observation so far? What my suggestion is, like I am first looking at the definition of AND. Definition of AND means like if you have two numbers, one bits you
can I solve it even with knowing this?
is verify A gives us B. If yes, print A. Otherwise say impossible. And yeah, that is essentially the idea for this problem.
Okay, so what they're basically kind of saying is that here in a sense for us B naught is A naught and A1, right? Every bit on B1 is also turned on in A1, which is true. So in a sense, A1 is simply A naught. Well, and for the same B1, A1, B2, every bit turned on in A1 is also turned on in A1 and A2. Sorry, B1 is also turned on in A1 and A2. And so in a simple sense,
is verify A gives us B. If yes, print A. Otherwise, say impossible. And yeah,
Okay, so they're saying like what is it? 3 and 5 should be A1. This is B, not B1, and this is 7. Or this is or. Now the same thing they're saying. So for A2, 5 or 4, and this, by the way, it's 5. It shows it's 5 here, but 5 is 101. 4 is 1 1. Sorry, 1 here is 0 0. This is simply 1 1 1. Now remember that A1 and A2, which is simply 1 1 1 and 1 1 1. We give 1 1 1. So, but this is not B. This is not B2. Mm. But let's get A. So B A2 in a sense is also, or 3 in a sense. B, or yeah, just make things simple. I'm just gonna um, zero index it, so A2, B1, or B, I believe, B2. Yeah, yeah, yeah. So A2 is I hope I'm showing the right screen. A2 in a sense. Well, A1 is B not or B1, which is 3 or 5, which we know is 7. And so A2 is 5. Or it doesn't really have to be 5, but because 5 is the one they gave us. But B, so remember, we're looking at A2. So B1 here is 5 or 4. And this is 101. This is 110. And remember, A2, A2. And if you increase it, this is just 7. This isn't 5. And you go here, you go A2 and A1, which they're both 7. So this will give you 7. But this is not equal to, I believe this is, what is it? What's the question? So A2, A1. Yeah, this is B2, I believe. No, 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 no. B1. This isn't true. So I guess his equation isn't
that is
necessarily true.
essentially the idea for this problem. Adjacent end of
It works, I guess, but what's wrong? What's going on? Hmm. So let's see. They're making the last elements equal to each other. Now they're going to be doing AJ is B, or now I'm just gonna do this on my own and see how the output will come out.
Of any consecutive element if it's not equal to bj, you got
Okay, I might have done something stupidly wrong then. What the fuck? Wait, so you're telling me that. So, wait, give me 1 second. So, you're saying 5 or 4 is 5? I am genuinely confused. So, let's. So, 5 is 1, right? 4. Oh, 4 is just this. Why I'm so fucking retarded. Oh my god. Alright, I guess that was my issue. Okay, whatever. This should be true then. Wow, this was more or less a bit painful, but it was fun. Why is it taking so long? I don't. Shit. looks. Oh, I have some homework to do, I suppose. Yeah, my next task of today is to do some homework. it has its, I guess, its perks. It's now okay. So believe I'm in number. Don't even know what number I'm in. But I started doing it just for the sake of. Okay, so I'm in question 4. So we use a baby step, giant step to find a discrete log of 5 for prime 47 and primitive root. And I can use MATLAB for computation. Okay, so they say use baby step and giant step. So first, so I'm finding the computation. They say I can use MATLAB, I don't need to. I guess the first thing I need to understand is what the fuck is baby step and giant step. Yes, even after the class, I don't know what these are. So let's look for baby step and giant step. So remember, we're just trying to compute our whatever it is, compute. I believe this for prime. This time uses baby step, giant step, whatever. So let's kind of do our little math thing. So Jesus Christ, it's a long page. here, okay, baby step, giant step. Here it is. So here's about baby step. Giant step works for P17. We want to, given this. It's not relatively, Jesus, thank God it's not that long, but let's see. Eve wants to find such x that a, this, x, b. She does the following. First, she chooses an integer n with n squared is less than, sorry, greater than or equal to p minus 1. For example, where x is the, okay, yeah, whatever. So it means, then she makes two lists. Doesn't really matter. She looks for a match between the two lists. If she finds one, then this is true. So a, ¿qué pasa? Okay, so yeah, this is a little bit, a little bit annoying, such an annoying problem because I'm actually like struggling right now. Um, so constructing two lists. Yeah, I'm just really reading this problem. I guess I'll use so we're getting baby step by giant step. All right. Okay. So the first list baby step is here, feet 3i, which but 10 is not the answer for x. 10 the 10 is just the matching value. Now, find where the match happens in the baby list. Oh, so if it was wrong. Okay, so I see. So basically, what we're doing here is like we should get the 10 years. So 10 is 3. You go. So we know that, right? It's 3i plus. I see. Such a complicated issue. Such a really fascinating problem. So what they're kind of saying is that we're gonna generate AJ and B. So let's do that. So the first thing they're asking us to do is one. This shouldn't be. This hopefully this doesn't take me too long, but so just gonna use monitor. Oops. So just here. Let's just put like first I believe we gotta start with our n. Oh, let's first define our values. So a is so a is I believe 5, and we're trying to p is 47, which p minus 146, but and we're trying to find L5, 10. Okay, so now that we get that settled, so we're trying to find 5x. We're trying to find x. So n, so let's put n squared. Obviously, this is just by inspection, we can easily see that n is simply because n squared is greater than or equal to 46. Or, never mind, they actually gave us a solution to do this. Well, round up. So yeah, it is 7 actually. Okay, so now we're constructing a list now. Uh, let's construct a list, I suppose. List one is, I believe, A. So, 5, 10, well, if it's mod pay, 15, 20, 25, 30, 35, 40. Oh, it's A to the power J. I'm stupid as hell. So it's gonna be 7 values. Now, 6, 25, mod 47, I believe, is 14. Oh, it's 125 first. Okay, sorry. 125 mod 47 is 31. Next value is 14. So 5 to the power 5 is, I believe, 3125. Now mod that by 47, that'll give you 23. So 5 to the power 6. Sorry, my math is not that high. But we know that the mod is 21. I'm using calculator, by the way. And last but not least, 5 to the power 7. Which I obviously don't know behind. Or I don't know instinctively. It's gonna be 11. So this is just next one is I believe. So now they're kind of saying that we should look for value. We don't know what B is, obviously. Let's see. Okay. Oops, I did. That's such a bad prompt. Super bad. So apparently we're actually given h is actually 10. H was 10 the whole time, which I never knew. Okay, let me just solve for a few. So basically what they're saying is 10 here. How do you solve for that congruence out? I think I know how to solve it, it's just it really is a little bit unfamiliar. Yeah, I should be fine. Oh, I see. Okay, understandable. So it's basically just that makes so much sense. I'll stop playing this song because I do not know whether I get copyright strike or not, so I'll change it. Okay, so that's one problem down, which took a while, which I really do hate.
Le soleil.
Okay, so next one is
Le soleil.
Alice is going to Alice is doing a diffy helmet key change with Bob. They're going to use prime P. Agreed to use the prime P30 equals 31, and A is what? Alice uses secret to be X equals 5. Okay, so Delphi problem. That I believe I do have some glimpse on it. It's not this one's not super hard. So Alice sends, I believe, so it seems that 1, 2, 3 doesn't really have a so it's 3 prime 5. Now, Bob now sends the public key equals 8. What the hell does that mean? Whoa. If Bob is sending 8, that means, I believe, K is simply, 8x, y, mod, obviously, mod 30. We don't know what, we know x, obviously. So Al sends 5A to it's just 478. So Bob sends Alice this. So Alice computes, I believe. Alice computes. She takes his value, 8, and to the power of 5 mod. Which I just kind of surprised. 8 to the power of 5. Mm-hmm. And Bob sends, so Bob sends this to me, right? That's a Y. And this is a Y right here. Mod P. So a Y. I'll be plus 3. So we do 8